afternoon. I'm Abram Ziegelaar. I'm from B.Braun, and I'd like to present to you today a practical approach, or at least how we are implementing a digital transformation. So, a little bit about the company. B.Braun is our mission is to protect and improve the health of people around the world. We do this through manufacturing a very wide range of medical devices, everything from catheters, that means needles, to plastic tube sets, plastic bags, surgical equipment, and intelligent devices such as pumps and dialysis machines. And we're doing this globally through 45 manufacturing sites. The practical implication of that is that we have probably every conceivable manufacturing archetype under the sun. So we've got repetitive discrete manufacturing, job shop discrete manufacturing, meaning highly manual stuff, so you'd know all about that. Yeah. We've got repetitive process manufacturing, so this is more from our colleagues in the oil and gas industry, so we've got continuous and batch and processes. The implication is we have a broad range of technologies, all sorts of systems and technologies and communication strategies. We have a broad range of use cases that we can apply technology, and a broad range of skills required to deliver all of that and put it together. Another driver is the convergence of IT and OT. We've heard about this in other speakers during the last few days. And for us, this convergence occurs at many levels. It's at an infrastructure level where we're actually sharing resources such as networks and things like that. At an operation and maintenance level where we're sharing and using IT technologies to monitor OT equipment and flag anomalies, for example. And in adopting the same system engineering and agile delivery approaches. So a lot of what we do is hardware and networking, but an even bigger part of what we do is software. And as we're in a regulated environment, the validation of the software and the systems that we build is very important. So we have to adopt agile ways of working and adopt a lot of what we see in the IT world. The reality, however, and PGT would have recognized that, and actually the oil and gas people did too, that we have a lot of technical debt. Yeah? What that means is that we have a fleet of machinery, which is perhaps anywhere from 5 to 40 years old. And they have all sorts of different communication protocols, communication capabilities, data availability, and we have to deal with all of that and somehow extract that information from all of these data ponds, if you like, or stranded data, you use the term, and bring it together in an organized way. Apart from that, the other challenges you have is network infrastructure, security, the heterogeneity of our legacy systems, non-standardized production processes, capability to support such a digitalized operational technology landscape with people skills and the maintenance and support infrastructure just to do that. And one of the other realities is, does management really understand what it takes to remove that technical debt in the first place just to get you over the first hurdle to equip yourself to then start doing things with the data? Just acquiring the data is your first hurdle. And that's a lot of what we do, is discussions with management to make them understand the reality here and what it's going to take to do this. So let's talk about what kind of data. As a manufacturer, that's what we do in a nutshell. We design our products, we manufacture it, and we support it throughout its life cycle, particularly for intelligent products. On the other axis, we have a supply chain. We source raw materials. and we make stuff and we deliver it through logistics. Now there's a whole pile of information domains here, and this is instructive from the point of view of understanding where does our data come from and what's the relationships of these data to each other. So this is like a Venn diagram to explain. The grey part here is more or less what happens in the ERP system. Then we have product and process design. This is your PLM world. Yeah, Siemens Teamcenter and 3DX, etc. Yeah, where you have a product model. Then we have manufacturing operations management itself, where we're collecting the real-time information coming out of production. Then we have plant engineering and equipment engineering. Yeah? And you can see here the overlap between these models is showing where do we share information and where do we have to contextualize information. Then we can extend that to our partners and the ecosystem of the people that we deal with. And finally, we get information back from our products out there in the wild. Yeah? So we learn from how people are using our products and the performance of our products, and we feed that back into our design and actually manufacturing as well. For the purposes of our digitalization, we focus on these areas here. And really it's the combination of product information, production, the facility itself and the maintenance around the facility, and the process of doing engineering, because engineering is the source of a lot of that data that we can get from the time of engineering and utilize that throughout the life cycle of the plant. So what's our approach? We started a global smart manufacturing program a couple of years ago, and the idea is to achieve vertical integration within the plants themselves and solve that technical debt at the grassroots level, and then horizontally integrate that at the site and enterprise level. At the enterprise, our main focus has been really evangelization of Industry 4. What does it mean? What are our targets? What do we think the ROI is going to be? Yeah, how do we convince management that this is a journey that's worth taking? And you shouldn't underestimate that task. Yeah? Furthermore, we've been aligning with IT and OT about strategies, not only on technology, but on about processes and how we do things. On the sites and the plant level, it's more about defining the use cases and removing that technical debt. So we've adopted a couple of philosophies, or guide rails, if you like, towards achieving this. One of them is to take a technology-based approach rather than a solution-based approach. What I mean by that is, in the old days, you would talk to the IT department, they would say, well, tell me your problem. What is your use case? And then they'd go away and they'd solve that one problem. And then you'd come along, well, what's the next use case? And we'd solve that one. The outcome of that is you end up with a bunch of different software, silo solutions, and you're just perpetuating the problem that we've had for the last 25 years. So we don't want to do that. We take a technology-based approach where we say we step back and understand the breadth and scope of the type of use cases that we want to achieve. And we say, what is the technology stack that will help us do all of those things? Not solve individual problems, but solve this whole raft of problems that we have. Not only the ones we know about today, because this thing's a snowball. Once you've solved those first problems, people realize, can I do that? Yes, we can. And then all these other use cases come out of the woodwork. So you've got a plan for the use cases you don't know about. Yeah? So the trick is to find a technology stack that you can live with for the next 10 to 15 years at least. Yeah? We call this our problem-solving environment. Yeah? The next philosophy we've taken is about systems thinking, that everything is a system. Yeah? The enterprise is a system of systems. Our organization is a system. Our products are all systems. No matter how simple they appear, they're all a system of components. Yeah? Production and facilities are obviously systems. And this is an important background because it drives your modeling process and allows you then to think about building real digital twins, not just a simple hierarchy and pegging some data to it. its systems thinking allows us to create the long-term, the digital twins that we're looking for. And we're doing that by adopting this IEC standard. It exists for the construction industry, making buildings and factories. Oil and gas are developing that. They have version 1 out there right now. And we have started an exercise with a consultant and several other large-scale manufacturers to develop an extension of this for the manufacturing industry. So, rabbit holes we've explored on the technology, on how to get there. So we have to get data out of machines, and then the grey and green boxes represent more or less what we tried to do with it. And then we scared ourselves by saying, what are the kinds of products we could get to solve that problem? And that just looked like a headache and too much hard work. So we said, okay, what are the drivers? We've got to have the minimum number of moving parts, keep it simple, the minimum number of skills needed to build and sustain it, and minimise the total cost of ownership. So how do we go about doing that? We said, this is a typical architecture of any manufacturing site. I think most of you would recognise that. The green bits are stuff that the IT people sort of take care of, and the grey boxes are all the stuff that we take care of as OT. And our technology stack ends up being, a thin edge to solve the integration problem of machines, thick edges to do aggregation. Then you end up with a fleet of these things, so you have to adopt an edge device manager that you can manage a fleet of devices. You don't have to run around with a laptop and USB sticks. And crucially, we have a backbone, which is our data manufacturing data management platform. And we chose Cognite, who have a booth over here. You're welcome to go and have a look at them. And that's our problem-solving tech stack. And that allows us to use the same tech stack irrespective of what the production archetype is, and we can use the same tech stack in all of our 45 sites. So, I come back to the second premise, which is about the information modelling, and we use the reference designation system because it allows us to create these rich models. So it's not just a simple hierarchy. You have a way of describing production processes and the organisation in systems. So it looks like that. They're the models we have: organisations, processes, manufacturing systems. Then we apply actual physical components to do that, and those physical components live in locations. So you end up with this rich model, and the benefits of doing all of that is that we have a common vocabulary to describe everything. And we can give a globally unique identification to everything. Yeah? And that helps us to create a unified namespace and a harmonized model globally for all of our 45 sites. So despite the historical mess we have over 45 sites and 50 years of automation, we can find a way to aggregate that in a harmonized way and analyze it on a global basis. Yeah? So, this rich model also then allows us to build the digital model, the digital shadow, and the digital twin. Yeah. And it supports building applications on top of it. Now that we have contextualized and harmonized data, I can build one application for one site, and because I'm in the cloud and I have a harmonized data structure, I can roll this out now globally. Yeah. So build once, deploy many. And crucially, because of the technology and the partner we've chosen, this creates a very rich model which we can then input structured data, unstructured data, 3D model from our engineering. Yeah, very important for in the oil and gas industry. Yeah. And we can time series and events. So all kinds of data can be put in this thing, and we can pass it in any direction and ask complex questions and use a GraphQL query. So they're very, very flexible. Okay, use cases. I like this picture. It's courtesy of SESME, but it kind of typifies what we try to do. This is one example. It's a shop floor management board. So next to each line, you have what's my problem today? What am I trying to achieve? Am I winning? Yeah, to use your vocabulary. But I like this picture because to answer those questions, you have to source information from many places. And our job is to allow that to happen in real time, that the guy on the shop floor has what he needs to do his job. This is our roadmap, and you see that's the shop floor management board is one of our applications. So we talk about maintenance and everything else. Maintenance is one of these dots. So we have a very large portfolio of applications we're going to build, all on top of the same data model, which is why the choice of your technology stack is very important, because I have to enable all of those things to happen. And on the platform that we've chosen, you can see here the orange dots are the stuff that we can more or less get out of the box, maybe with a little bit of tweaking. And the purple stuff is stuff that we can use the capabilities of the platform to build applications more unique to what we want to achieve. And it's not out of the box, but the platform helps us do that. That's why I call this the backbone of our problem-solving technology stack. Okay, so it wouldn't be complete if we didn't address how do we build it and how do we support it. It's okay to have this shiny new object, but you've got to actually maintain it, or build it and maintain it over time. So here you see we're using Microsoft Azure DevOps and modern requirements as part of our engineering workflow with CI/CD. And we're using that as a collaboration platform with Cognite to actually do the engineering. And then we're using shared IT infrastructure to support our OT equipment. And the last slide here is on the support side, we've created a digital connection from our support environment, which is ServiceNow, and we've integrated that with our prime vendor in their Zendesk, so that our ticketing system, so our end users can then raise tickets and have visibility as to what's going on any issues that they've come up with. Yeah, so that once we start deploying applications, we have the mechanisms to support it all. So that's it in a nutshell. Thank you very much, and you're welcome to find me and ask questions later. Thank you.